Hello there. Good evening, good afternoon, good morning. So this side Himanshu Pareek, and I am physics faculty here at askIITians. And today we are going to discuss the chapter called the basic maths. All right. So just I hope you have just entered in the grade 9, and the first chapter which you are seeing in physics is the basic mathematics. So you all might be getting scared that sir, why we have a mathematics in the physics course. So actually, the point is, it is like a preparation for the upcoming chapters. Because so far, what we have been doing in the grade 6, 7, 8, we have been learning the forces, we have been learning about the heat, temperature, many other phenomena, right? But the mathematical touch was not there, right? We have been trying to learn their theoretical touch. Okay, but now when you start your subject from the grade 9, from grade 10, you will find that the mathematical calculations are also coming. So if mathematical calculations are coming, then for that we need to use some maths as well. But the mathematics which is required here in physics, especially in the grade 9, right, 10, and of course in grade 11 and 12, is little bit different. Right. It's not now simply which we have done before. 3 plus 5 is equal to 8. Okay. So there are different branches actually. Statistical mechanics, then calculus, algebra, trigonometry. I am going to discuss with you the vector algebra. Right. That's a portion which we are going to cover first of all, the vector part here. Okay. Now see, why do we need this vector algebra? What is the purpose of it? I mean, what if I don't study this chapter, right? What will I lose? So let me explain you first of all, right? You can see this wallpaper here. That's a very nice wallpaper, but many things are shown over here on the wallpaper, like this pulley you can see, right? Then the spring balance also is there. Many things are there. Now to understand, yes, of course, I can say at the end of grade 12, you would be able to understand these many things, whatever you can see here on the wallpaper. Okay. So now the point is, why do we need vector algebra? What is the purpose of it? So purpose is actually, see, let me start with one example. Okay. Suppose you are at your school, right? And now someone has come to pick you up from there, from your school. And you call him and you tell them that I am standing 2 meters away from my school main gate. Okay. That's a perfect address as per you. Like as according to you, you have given him that I am standing 2 meters away from the school main gate. Do you think that he would be able to catch you? Like whether you are standing? I don't think so. Think about it. See, what is the question? What I'm asking you is you are standing 2 meters away from the school main gate. That's the address you have told to your parents, let's say, your brother, let's say. Now the point is whether he would be able to pick you up from there, whether he would be able to meet you. Answer is no. Because you have not specified the direction where you are standing exactly. All right. So basically, the place where you are standing and the place where is the school main gate, the distance between them is 2 meters. That's pretty good. Right. So suppose you are standing here and the school main gate is somewhere here. Now, how would that person know? You just told him that 2 meters away from the school main gate. How would he know that 2 meters from on this side, 2 meters 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 this side? Are you getting my point? So actually, we don't know in which direction, he doesn't know in which direction you are standing there. So which creates a confusion. Means the answer which you gave to him that I am standing 2 meters away from the school main gate, that was not the wrong answer, right? But it was an incomplete answer. You also need to specify the directions. All right. So basically, to define your position, I need to know your direction also. Are you getting my point? So the point here is There are some physical quantities. What do I mean by physical quantities? Physical quantities means something which can be measured. That is called a physical quantity. So if you want to tell the number, let's say you want to, I hope you are aware of the terms called speed, accelerations, and all such things. So suppose if somebody wants to measure the speed, velocity, let's say, right? So for that, we need to also specify the direction as well, in which direction the body is traveling. Otherwise, let's say you simply say that a car is going at a 40 km per hour, right? And now, definitely, you cannot say that in which direction the car would reach. Where will the car reach? Suppose the car is standing here. And now somebody says that the car has started traveling at a speed of 40 kilometers per hour. But you would not be able to say that whether the car will reach at this point, or the car will reach at this point, or the car will reach at this point, or at this point, or at this point, or at this point, until you don't specify the direction. Once you specify the direction, yes, the car was traveling in the north side. So once you say that the car was traveling towards north, then it becomes pretty clear that car would reach definitely here. After, let's say, certain time, it would be crossing this place. I hope you have got my point. That what is the theme? The theme of this chapter is there are some physical quantities which do requires the direction for their representation. That's what we call the vector quantities. Okay. So welcome to the chapter called vectors. Okay. And now I'm going to basically in this particular class, we are going to have the simple introduction. So you don't need to worry about it that I will be using too much mathematics here. No, it would be just a very simple session where I am just going to use the theoretical touch. What is a vector in more detail, comparing it with scalars. Then why do we use vector? Of course, I have told you one or two examples, but little bit in more detail we'll be doing them. Then representation of vectors. How do we represent them? One thing you should all notice here that this is something new you guys are learning. So you should be ready to accept them. Every time you should not be able to question. We will not be able to answer them. That why the vector is shown by this particular thing only. We could have used this as symbol also. So it is just an historical reasons, right? And our ancestors have used those symbols, so that's why we are also using them. Okay. So don't worry about the symbol part and all. So coming to the topics which we are going to cover in this lecture: vectors, representation of vectors, types of vectors, and then angle between the vectors. So don't worry, no mathematics in today's class, but yes, the next lecture which we are going to have on this topic would definitely have a lot of mathematics. So be ready with that. And yes, we will need some trigonometry for that also. All right. So now I'm going to start this chapter called vectors. So I hope you have got the idea why do we need vectors a little bit. Ongoing with the chapter, you will get more detailed part of it. Okay. So let us begin now. So as I said, what is a physical quantity? Something which can be measured. That is called physical quantity. Something which can be measured is called a physical quantity. Perfect. Now, what can be measured? Mass can be measured. Volume of an object can be measured. Temperature can be measured. Getting my point? Then, what else? The weight of a body can be measured. Okay. Then, how fast you are moving, that can be measured. Then, what else? Time can be measured. Okay. In chemistry, I don't know whether you have heard of it or not. Moles, number of moles can be measured. So all these things are physical quantities. We divide these physical quantities into two parts. Right? Why I'm doing this dividation, that should be first of all clear to you. My first requirement here is because I need some physical quantities. There are some physical quantities which do require direction. Right? Now, so one is called the scalar and other is called the vector. So scalar means the quantity which requires only magnitude, and the vector means the quantities which required magnitude as well as direction. Are you getting my point? So The scalar quantities. Let's start with an example. Suppose you measure the temperature. Let's say some person is having a fever. Okay, this person is having a fever. All right, and now you come there and you measure the temperature of his this person, and you get, like, of course you will be using the thermometer or something. Okay, so you get the count as, let's say, 98, 99, whatever. Okay, now you say that this is the reading. Let's say you say that 102. Okay, you said 102. Of course, do you mention that it is 102 in this direction, 102 in that direction, 103 in that direction? No, we don't say like that. We just simply say that the temperature is 102. That's it. We never mention that 102 in left side, 102 in right side, because that is meaningless. Getting my point? Okay. Let similarly, if I ask you to measure the mass of this person, right? Though he is sick, but still we are doing our whole experiment on this person only. Okay. So if I ask you to measure the mass of this person, what you would say? That mass you will be measuring with some instrument, whatever device you'll be having, and let's say you got with the answer of 40 kg. Now would say that the mass is 40 kg, but do you also specify it is in north, east direction, west direction? I don't think so. We never specify that. You brought vegetable from the market, 3 kg vegetable. You never mention. I brought 3 kg vegetable in east direction. That does not make any sense also. Are you getting my point? So those quantities which do not require any direction for their complete representation is called a scalar quantity. Okay, so has magnitude only, that number. That's it. Apart from this, if we talk about vector quantities, then vector quantities are those quantities which do require directions, right? Here we can mention some examples. I forgot to mention it here. One is mass, other you can say length. Length is of course a scalar quantity. Suppose you take let's say you want to calculate the length of this mobile phone, right? So if you want to measure the length of this mobile phone, you would be using one ruler. Okay, so that scale you will be using here. Okay, and then you will put the scale here. Now, does it matter whether you keep it like this? It doesn't matter. Exactly. So basically here the length is also a scalar quantity. Then temperature is also a scalar quantity. Getting my point? Right. Then volume is also a scalar quantity. Okay, we do not specify in which direction the volume is. Then if I talk about vector quantities, then first of all the quantity which comes out to be, which is the velocity. Many quantities I'm not discussing here because then it would become a 10-hour lecture. I'm just discussing only those quantities which you know already. Okay, so now it's your duty to relate whether it is a scalar or vector quantity in physics. Whenever your teacher tells you that now today I'm going to teach you this thing, any quantity which he says, now you should be able to think that whether the quantity which I'm going to discuss now is that is a scalar or that is a vector. That you should be able to answer now, right? Okay, now velocity is a vector quantity. All right, then displacement is a vector quantity. We know it very well. Displacement is a vector quantity. Okay, so if you don't know displacement, don't worry about it. You'll be learning it, so don't worry. Okay, so velocity, I guess you know, so that's why I have mentioned it, that velocity is a vector quantity. It requires a direction, in which direction you're going. If you don't know displacement, don't worry, it will be covered in the next chapter, right? The motion chapter of physics. Okay, so going ahead now, I hope you have understood what is scalar, what is vector. So there are also some other examples which they have shown: length, temperature, charge, pressure, frequency, mass, volume, time, speed. All these things are the scalar quantity. Energy is also a scalar quantity, right? 200 joules of energy, 300 joules of energy, like power you take. Suppose 300 wattage of heater, 500 wattage of heater, 1000 wattage of heater. So these things do not require any direction. Are you getting my point? So that's the thing here. Okay. Now let us understand vectors here a little bit more. Okay. Right. Now, okay. So suppose this guy, we can give him some name, Sonu, and this guy name, Monu. All right. Okay. So Sonu and Monu both are standing there. Okay. Now, first of all, the Sonu, first of all, like the Sonu, I'm not recognizing that what question they are asking. Right. But let us guess something. Right. So let's say the Sonu has asked a question to Monu that where you are standing, which I gave you earlier. And Monu has given the answer that I am standing 10-meter away from India Gate of Delhi. 10-meter away from India Gate of Delhi. Let's say Monu has replied to Sonu. So again, the same thing. Would Sonu would be able to reach there? No, because Monu also need to specify in which direction he is standing. 10-meter away. Like if suppose if it is an India Gate, now there are many ways, right, to go 10-meter. You can go 10-meter here. 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 In multiple directions, you can go. I hope you have got my point. So now the thing is 10-meter in which direction? That is very important to specify. All right. Okay. So suppose you now if the Sonu tells that I am standing north of India Gate, then you get to know, okay, north means I know and I have to go in this particular direction only. And then you go 10-meter this side and you will find Mono is standing there. Okay. So that is the role of vector quantities. On the right side, you can see some numbers are shown. What is the significance of these numbers? Let us see them. It's very important to understand. After understanding these numbers, this right side wala example, you would be able to have a very good idea about vectors, of course. Right. Here I'm going to talk about little bit about the addition of vectors also. Of course, keep one thing in the mind. When we talk about the vectors, then it's a different mathematics. So simply you cannot say 5 plus 5 is equal to 10. Why we cannot say like that? I'm going to give you some idea about it. Don't worry. Okay. Why the vectors are so special? Why their mathematics is so special? You will get the entire idea from it. Okay. So don't worry. Let us discuss it here. Suppose you have one box. We have already one example here. So we can pick that one only. Okay. Let us take the example of this person. These two people, right? We can give them again some name. Sonu, Monu are in one team. And this side, who is standing? We can take some name. Tonu and Ronu. So 4 people are standing here. Monu and Sonu in brown color team. And Tonu and Ronu are in the another team, which I have mentioned with the blue color. Now, it seems like there is one guy only here. Okay, the guy is hanging and the guy is tied from a string. Right. So we can give him some name. Okay, his name is Bunty. Okay, so now both the Sonu Monu team and Tonu Ronu team are trying to pull the Bunty. Okay, so let's see who will win. Okay, so what I'm going to see, what I'm going to check, I'm going to measure the total force acting on Bunty. Total force on Bunty. That is my job here. I'm going to calculate that. Okay, so let us go back to the previous slide. Let's say that Sonu and Monu team is exerting a force of 5 Newton in rightward direction. Okay, and the another team is also exerting a force of 5 Newton in the rightward direction. Are you getting my point? So basically, this is, let's say, Bunty. So Sonu and Monu team is exerting a force of 5 Newton in the rightward direction. Then Tonu Ronu team is also exerting a force of 5 Newton in the same direction. What will happen? This guy Bunty will get a total force of how much? Of course, 10 Newton, right? In the rightward direction. So, of course, Monu, Sonu, and also was pushing him, the Bunty, and Tonu, Ronu were also pulling him. Okay. Don't go to this example. Try to look at that diagram, this diagram, the example one which I have taken. Okay. Second example. Suppose now what happens? The Sonu Monu team is exerting a force of 5 Newton on the rightward direction. So again, this is the guy Bunty here. Okay. And the Sonu Monu team is exerting a force of 5 Newton in this direction. Please do not look at this example. This is just one of the pictorial representation. Let me remove this part from here if you're getting confused from it. Okay. Do not get confused from it. I'm showing all these things separately here on the left side. So first case, the Sonu Monu team exerting a force in the rightward direction. Then Tonu Ronu team exerting a force in the rightward direction. Total force 10 Newton. Second example, the Sonu Monu team is exerting a force of 5 Newton in the rightward direction. But you see this arrow? It is going in the leftward direction. So what we will say that the Tonu Ronu team is exerting a force on this body in this direction. Again, the 5 Newton. Now, if you don't know mathematics, the vector mathematics, of course, anybody would say that the total force is 10 Newton now. 5 plus 5 is 10. That's how we add two numbers. Yes or no? Suppose 5 kg chini, 5 kg chini. So obviously 10 kg of sugar. All right. So similarly, 5 Newton force, 5 Newton force. 10 Newton, simple, but answer is no. If you say that answer is 10 Newton here, then your answer would be wrong here. Answer is not 10 Newton. It is wrong. So if it is 10 Newton wrong, then what does it mean? Why it is wrong? Because now you're dealing with a quantity which is not that simple as you have done before. Okay. So here this 10 Newton of force is acting. It is wrong. Here the total force is 0. We also need to look at the directions. 5 Newton from this side, 5 Newton from this side. So total is 0. Don't worry, you will be having more idea about it. But that's what I'm trying to tell you here. The total force is not 10 Newton. The answer is 0 Newton here. Okay. Other examples are also shown. 5 plus 10, 15, same direction. 5, 10 opposite. So net is towards left, minus 5. Similarly, you can see the another example here. 5 plus minus 15. So net is minus 10. Okay. Then vertically also, one example is shown. So ultimately, what you should understand from this is that addition of two vector quantities is also not a same thing as we used to do in our grade 8, 6, 7, 8. That is wrong. Okay. So vector quantities are not added in the same way. Like 5 plus 10 is 15. It is not always necessary. It depends in which direction that 10 is there. Okay. But I'm not talking about only vector quantities. Don't do this with temperatures and all. Okay. Going ahead. So representation of vectors. Okay. So how do we represent a vector? So as you can see here, one is the head part and another is a tail part. Okay. So let's say the force is in this direction. This way. So what I would say that I will show the arrow like an arrow, and head of that arrow would represent the direction of force. Okay. And this is the tail part. Okay. So this way. Got my point? One more thing here, which you can learn it at this stage itself. I hope you have understood this point. So we can also make clearance about one more thing here. Length of this arrow. If you measure the length of this arrow, of course we can measure it. The length of this arrow is representing the magnitude of vector. So vectors are usually represented by the arrows, of course, correct. their length representing the magnitude, and their direction represented by the direction the arrow points. The vector required both magnitude and direction. We have understood this, no confusion about it. All right. Now, so basically, this is how we will be representing any vector. Suppose, let us take one question. Suppose if somebody asks you in the exam that one vector is like this and other vector is like this. Let's say the force is shown. Okay, F1 and F2. Which force is greater? Simply we can say F1 greater than F2. Magnitude of F1 is greater than magnitude of F2. Got my point? Okay. But guys, see, whenever I will be writing this vector thing in a for some calculations, suppose I'm teaching you a topic called force. So force is a vector quantity. It requires direction for the representation. Okay. Now I would not write, let's say the force is 10 Newton. So every time I will not represent it in this way. Yellow, 10 Newton. If somebody says force is 100 Newton out of laptop screen. So we will not do that every time. So there is a better method, right? How we can show these things, which I am going to teach you later on. How do we show this direction part of a vector? So don't worry. Every time we don't follow this notation. Okay, so that is the basic part which I have told you. So any physical quantity which is a vector would be known by this symbol over it. This arrow you can see. If you see this arrow, that means it is a vector quantity. Got my point? All right. So this is like the symbol of vector. Okay. If this symbol is present over any now onwards in physics, whenever you see any book, at least you should be able to answer if you see any arrow like that. You should be able to say that, yes, this arrow is there. Yeah, it is a vector quantity. Yes. And my teacher would teach me how to deal with it, right? In the upcoming sessions. So you would have the clear idea about it, that how to add these quantities and everything. Okay. So always remember, always see it by this symbol only. I hope you have got my point. Okay. You don't have to represent the actual length of the vector here. Suppose if somebody says force is 10 Newton, then please don't do this. No, a very small symbol arrow you have to show. Just it's not notation. It's a representation. Okay. Okay. So let's now going ahead. Let us discuss the types of vector. So types of vector, yeah, types of vector means first of all the zero vector, right? Okay, so zero vector means the vector whose magnitude is zero. The vector whose magnitude is zero. Let us discuss some examples of it. Okay, many questions have been asked. I will discuss all these questions, right? So actually, you know, my like during the teaching part, I am also covering some important questions. So you keep making the notes of it. Okay. So suppose somebody says the force is 0 Newton. You know now why I'm putting that vector sign there. Okay. So force is equal to 0 Newton. This is a zero vector. That's it. Simple. Now, many times we get a question like this. What is the direction of zero vector? What is the direction of zero vector? We would say zero vector direction. The force is not even acting. How it can have a direction? Yes or no? Exactly. Its direction is undefined. It can have any direction. 0 Newton force. It can be in any direction, no? Right. So its direction is undefined. Next, co-initial vector. These are simple things. Co-initial. See, this symbol, this prefix, you will see many times in physics. Co. Co means same. Co means same. Okay. So that's how you can, like, at least you can interpret it. You will be able to guess what is the topic about. Same initial vector means the starting point is same. Okay. So co-initial means the starting point is same. Suppose let us take an example. Let's say we have a box. You are exerting a force on this box. Let's say one force is being exerted here, 2 Newton. One force exerted here, 10 Newton. One force exerted this way, 20 Newton. One force exerted this way, 100 Newton. One force exerted this way, 30 Newton. So starting point of all the forces are same. It is called a co-initial vector. I hope you have got my point. Okay. So starting point is same here. That is why we call it a co-initial vector. All right. Okay. So starting point of a vector is same. It is called a co-initial vector. That's it. Okay. Magnitude can be different. Okay. Next, going ahead, the second part, next part is co-linear vector. The vectors which are along the same line. The vectors which are along the same line. So there is, you can see one trolley here. So one person is pulling this way. Sonu is pulling this way. And Monu is pushing it this way. Monu could have pulled it also. So if you join their line of action of force, they both are exerting force along this line and this line. So line of action of force are same. That is called a co-linear vector. Vector along the same line. Again, you can see that word co is there. Co means same along the same line. Coplanar, I hope you would be able to make the definition now yourself. Co means same in a same plane. Okay, in a same plane. Suppose I have this book. Okay, and now I am exerting the force. One force I'm exerting this way. Let me hold it. One force I'm exerting this way towards right side. One force I'm exerting this way towards left side. Ignore the thickness of this book. Okay. One force I'm exerting this way. 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 So all the forces are acting in a plane only. Got my point? Or you can take one paper in your hand. Take one paper in your hand and now try to pull it from other different sides. Right? So all these forces are acting in a plane only. So when these forces are acting in a plane, it is called a coplanar vector. Got my point? Okay. So vectors which lies in the same plane is called a coplanar vector. I hope these things are very simple. You're able to understand them. Okay. Now the another thing is equal vector. Equal means equal, right? But here we need to know one thing. When I say that equal vector, then equal means magnitude as well as direction. Both things should be equal. Okay, so if I'm saying the vector is equal, which means that magnitude as well as direction, both the things are same. It should not be like that only and only the magnitude is same. No, if somebody says force 10 Newton, let's say Sonu, let us call Sonu again. Sonu ne kaha, Sonu said ki I am exerting a force of 10 Newton on the box. Any box you can pick, this trolley you can say. Okay. Sonu said I am pulling the trolley with a 10 Newton of 35 Newton of force. हमने कहा very good, nice. Then Monu said I am exerting a force of 55 Newton. 35 Newton, sorry. This is the force by Sonu, 35 Newton. And force by Monu is 35 Newton. Just by this information, we cannot say whether their forces are equal or not, because we have not yet specified the direction. All right. So basically, Sonu said I am exerting a force of 35. Monu said I am exerting a force of 35 Newton. But that doesn't mean their forces are same. Their forces ke magnitudes are same. When do we say two forces are same? When the directions are also same. I hope you got my point. All right. In this case, they are not same, because you see Sonu and Monu forces are opposite in directions. Sonu left, Monu right. Okay. So if Sonu would have exerted this way, if Monu would have exerted this way, exactly, we would have got the same forces. Okay, so direction also has to be same. Okay. If this thing is not if this thing is not there, if magnitude and direction are not same, or let's say magnitude is same but direction is not same, or let's say direction is same but magnitude is not same, then it is an unequal vector. Okay, so they have shown here what is the meaning of unequal vector. Position vector, हाँ ये important है, we should know what is position vector. So let us see this. See, if you want to define the position of any body, any particle, right, or any system, of course we make always one coordinate system in our mind. Okay, suppose you are standing here and the person is standing here. You want to locate this person. What you would say? That first I need to walk x 10 meter in x direction, and then I need to walk, let's say 5 meter in y direction. Okay, so now this will define the position of a body. That to reach at this point P, I had to use this much length in x axis and this much length in y axis. Got my point? Which is shown here as A1 and here it is shown as A2. So A1 in x axis and A2 length in y axis. See, this length, do not get confused. This length and this length is basically same only. Okay. So if the observer means the person who is measuring the position, the person who is measuring the position is sitting here at this location, observer, and the man is standing here whose location you want to specify. So observer would say the man is standing A1 to reach at the location of person P, right? Observer would say that you have to walk A1 in x direction and A2 in y direction. In much more better way, I will be representing it very soon. Just wait for 2 more minutes. I'll be coming up with a very good, very special type of vector. After that, you would be able to locate him. How do we show this exactly in physics? In the vector physics. Okay. That is the unit vector. Here I'll also explain you again the position vector part. Okay, so let's have a look on this part now. It's a very wonderful concept. Okay, let's see. Unit vector. So when we started this chapter, I said that I will use the we will like I said that the vectors are something which requires magnitude as well as direction for their complete representation. Absolutely correct. Okay, so suppose I am having some physical quantity V. Okay, so it is represented by this symbol. How would I write it? First of all, I am going to write the magnitude of this physical quantity. Magnitude of this physical quantity. And then I am going to specify the direction here. Right? So magnitude, and then along with the magnitude, you will be mentioning the direction. So that's how we will be representing the vector quantity. Okay. Magnitude and direction is associated with it. How do we associate the direction here? That's the important question. Okay. Like, how do we write it? Do we write it like X, Y, Z? No, 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 no. We don't do that. There is a better way to write down all such things. Don't read the definition right now. Do not get confused. You'll understand in the end. First of all, we should have this clear idea in our mind that if I want to mention the direction of something, suppose I said force is 10 Newton. Okay, if I'm saying that force is 10 Newton, then I should not be saying the direction is like when I'm writing the direction here, this factor gets affected. Let me explain this part once again. See, I'm saying that the force is 10 Newton. Okay. So if the force is 10 Newton, then I will specify the direction there. Now, when I'm writing the direction here, X, Y, Z, whatever, in whatever ways I'm going to write, that should not affect this magnitude. This magnitude should remain 10 Newton. So, whatever direction I'm going to use here, that would be a vector only. See, how to specify a direction? Using a vector. Okay, so whatever vector I will be using here, what should be the magnitude of that vector? It's a common sense. 1. If its magnitude is more than 1, it will get multiplied with 10 and it will affect our answer. Then force will not be 10 Newton. It will, let's say, 20, 25, 30, whatever it can become. So what I'm saying, it's a very common sense thing that unit vector has to be have the magnitude 1. Why? Because if we have the unit vector magnitude not 1, then it will have some multiplication factor with the actual value of force, and that will totally change our answer. So we will not do that. Okay, so that's why we will write down the direction here using a concept called unit vector. So unit vector always has the magnitude 1. The first line is clear, and it is used to show the direction of a vector. That's the purpose of the unit vector. Okay, so now first of all, let us learn how to write down a unit vector. Okay, and then we will learn how to how to how to use it. Okay, so be careful, like be attentive here. This is little bit complicated, so in the first go we usually don't understand it. Okay, so let us start learning this part. Few things you need to accept here. If you want to write down the direction in x direction, if you want to represent something in x direction, we will be using the symbol called I cap. It's an I cap, cap over it. Okay, if you want to specify something which is going in y direction, we will be using j cap. If you want to specify something which is going in z direction, k cap. Okay, that's a k cap. I hope this point is clear to you all, that I cap means x direction, j cap means y direction, and k cap means z direction. Okay, so if somebody says, for example, particle moving in x direction, you're running in x direction, running in x direction with the speed 2 meters per second. How would I represent it? What should be the velocity of the particle? Velocity vector. I would just say 2 I cap. X is the direction and 2 is the magnitude. Got my point? If somebody says particle is running in minus x direction, minus x, speed 2, how would I represent it? Minus 2 I cap. Means jahan pe I cap, where there you place minus I cap, if it is minus. Suppose the stone is falling downwards. with a speed of 10 meter per second. So how would I represent the velocity? Try to write it in your notebook. How would you represent the velocity here? If the particle is falling down with with a velocity 10 meter per second, we will mention minus 10 j cap, because j cap y, because y axis, and y minus because down. अगर ये ऊपर जाता, if it would have gone up, then plus 10 j cap. So I hope you have understood this. Why, how to use it? Okay. So 10 I cap plus 10 j cap. I hope it is clear. X direction, I cap. You forget about the Z direction, right? Okay, don't worry about it. You're learning it in the higher grades. But right now, let us focus on 2 dimensions only. Because in your grade 9 also, we are going to discuss motion in 2 dimension. So do not worry about 3 dimension right now. You will get unnecessarily confused. Okay. So once you learn the 2 dimension, it's very easy for you to extend it to 3 dimension. Okay. So let us see again. Suppose you want to say that if body is going x direction, in x direction with a velocity of 2 meter per second, then how would I represent the velocity? I would just say 2 I cap. Got my point? Okay. Now, similarly, we can represent the position vector. So as I said before, I am going to specify the position vector once again. So try to learn this here now. It's a very, very important thing. Now, this is something which is important for you guys who wants to go ahead in physics, especially for JEE, NEET, Olympiads, KVPY. It's a very important thing to understand how to write a position vector. Suppose this is origin, this is x-axis, this is y-axis. The particle is here. The coordinate is 2, 3. Coordinate, you understand? Coordinate means I have to go 2 meter in x direction and then 3 meter in y direction. Okay. So how do we write down the position vector? You start a vector from origin and join the particle from there. You start a vector from origin. Just a second. You start a vector from origin and join the particle. This will represent the position vector of a particle. That's it, simple. Suppose if I ask you how to write this position vector in that I cap j cap format. Very simple. You want to write down the position vector? Let us represent it by r cap. R vector, sorry. R vector. So how I'll be representing it? So I will say 2 meter I cap, 3 meter j cap. Simple. 2 meter I cap, 3 meter j cap. Let us practice this part now. Let us practice this little bit. Just a second. Another question. Next question. Suppose the particle is here and the coordinate is 4 comma minus 4 comma plus 4 comma minus 5. How would I write the position vector of the particle? So first of all, let us show this on the x-axis in the plane, the position vector. Start the vector from origin and join the particle. Simple. How would I represent it? R vector is equal to, so 4 meter in x direction, so 4 I cap, then minus 5 j cap. Simple. Let us practice few more questions. Suppose you want to specify this particle location. -1, -2. Okay. So what I would say, that to reach at this particle, minus I cap, 1 you don't need to write, -1 I cap, that is not required. है ना? Simply you can keep minus I cap. Okay. So just we can remove it from here. So minus I cap and -2 J cap. That's how we represent the position vector of any point in the plane. Now you see, you can extend the same discussion to 3 dimension. If you go to, suppose you want to locate the position of a mosquito and the origin is here. So 2 x direction, then y direction, this way, and then z direction. So for z direction ke liye, we will use k cap. So I hope it is simple now. I, j, k. That's it. Okay. So that is the meaning of, that is the use of unit vector basically, because I cap didn't affect the magnitude. I cap itself is having a magnitude 1. Okay. One more thing, let me tell you here. How do we represent, how do we specify the magnitude of a vector? ये भी एक तरीका होता है. जैसे मान लीजिए कि सपोज you are having a vector r vector. Okay. So how do we represent the unit vector? Cap over it. How do we represent the magnitude of a vector? Mode of r vector. This mode thing is representing the magnitude. या फिर simply you can represent r. That's it. No, don't put any vector sign. This thing is representing the magnitude of a vector. This thing is representing the magnitude of a vector. That's it. Okay. Let's go ahead. I hope you have got a clear idea what is a unit vector. Okay. So now let us go ahead with the angle between two vectors. Now there are some rules. Suppose if I ask you angle between two lines, you would say that, sir, this is the angle between two lines. Some angle, let's say theta. But if somebody says, can't this be the angle between two lines? Answer is yes. It can be the angle. So we don't need to worry about it. But when you specify the angle between vectors, तब हमें क्या करना होगा? So first of all, make sure whenever you are finding the angle between two vectors, tail of one vector, sorry, should be joined with the tail of another vector. Important. Okay. So suppose if I give you one vector like this, F1 vector, and another vector like this. I said, what is the angle between two vectors? Now it looks very difficult question. How would I find this angle between these two vectors? They are not even intersecting to each other. अब आप एक बात देखिए, if you extend this vector, तो क्या इसकी डायरेक्शन चेंज हो जाएगी? नहीं. भाई, अब somebody said कि 2 मीटर in x direction. अब वो 2 मीटर ऐसे बोले या 2 मीटर ऐसे बोले, it's the same thing. Yes or no? So basically direction would be same only. If 2 meter x direction, 2 meter x direction, wherever you represent it, it would be same. Similarly, what I'm saying, that we can extend this vector like this. And when you extend the vector, the head would reach here. Extend, instead of extend, I should say the correct term is, we can shift this vector. Okay. So this vector was originally here. Let me draw it again. This vector was originally here at this location. If you want to find out the angle between F1 and F2, what you can do, you can extend this vector, you can displace this vector here like this, F2, without changing its direction. parallel to itself. All right, parallel to itself. Just displace it. Now you have seen that they are joined tail to tail. So this would be the angle between the vectors. So here also you can see the two vectors are joined tail to tail. Okay, and that's how we will be getting the angle between these two vectors. Got my point? So basically, what did we see in this topic? That the angle between two vectors ke liye, we have to join the two vectors tail to tail. Suppose we can take one more example. Suppose let's say one vector going this way and the other vector coming this way. Other vector is coming this way. What to do? You displace any of the vector. Let's say if somebody said, I will displace this blue color vector. Yeah, you can do that. Right? You can do that. Okay. So for that, what we need to do? We need to, first of all, shift them. Okay. So this blue color vector, I'll be shifting like this way. Okay. So this blue color vector, I have shifted a little bit towards right. Similarly, what you can do, this red color vector you can bring down. This red color vector you can bring down. And now you see they are joined tail to tail. ध्यान आपको ये रखना है कि you should not displace them. You should not change their direction. Uske parallel ही you have to shift them. So you can see here the blue color vector I have shifted this way. Red color vector I have shifted this way. Okay. So this is the angle between two vectors. Alpha, however the symbol you represent. Okay. So that is what is the angle between vectors. So what did we learn today? First of all, what is vector? Then we discussed about the definition of vector having magnitude as well as direction, some examples. Then we understand this example, like how to add two vectors. It is not simple 5 plus 5 equal to 10. It can be 0 also. 5 plus 5 can be 0 also, depending upon how 5 and that 5 is acting. Then representation of vectors, that tail head arrow part. And then finally, co-linear types of vectors: 0, co-initial, same point. Co-linear vector means same along the same line. Co-planar vector means in the same plane. Equal vector means same magnitude, same direction. Finally, position vector, but that position vector part we discuss in the end in the very much detail. And for that, the important part is a unit vector. All right. And after learning unit vector, we came to this part, that the position vector. How to write down the position vector. And finally, we discussed about the angle between two vectors, that they should be joined tail to tail. Okay. So that's all for today, guys. Okay. I hope you have understood this topic, and I hope you have enjoyed the lectures. Okay. So thank you so much. Bye bye.